Hey math kids, today we're going to talk about cumulative frequency graphs, and we're in chapter 12, section I. And yeah, we'll start with talking about percentiles. Okay, so a percentile is the score below which a certain percentage of the data lies. So if you're looking at your ACT score and you're in the 50th percentile, what that means is half the data is below you. So half the people who took the ACT scored lower than you, and half the people who took the ACT scored higher than you. You're right in the middle. So that's different from like a percentage, because most of the classic way to interpret that would be I don't know, probably something like a B, where half would be above you and half would be below you, something like that. So remember, percentile is just what percent of the data lies below that number. And so if we're looking at quartiles, Q1 is the same thing as the 25th percentile. Q2, which is the median, is the 50th percentile. And then Q3 is the 75th percentile. Okay? Now there's just one example. It's kind of big though, and so we'll just start there. Okay. So I'm going to draw a table. So we have time. Oops. So time measured in minutes, and then just frequency. Now, this will take me a minute because we have these ranges. 146. Once again, it's probably going to be easier to read this in your book. $154, $156, $158, $160, $168. And then these are all less than or equal to. These are all T. And then this is all less than. And then 150, 152, 154, 156, 158, 160, 168, and 176. All right. Almost there. So we got 8, 3, 9, 11, 12, 7, 5, 8, 6. Okay. So the data shows the results of a women's marathon at the 2008 Olympics for all competitors who finished the race. Add a cumulative frequency column. Okay. So all cumulative frequency means is that we add it up as we go. So cumulative frequency. So the first one's still going to be 8. But then since this is 3, we're saying at this point in the race, 11 people have finished. Then we add the 9. We get 20, add that, 31, 43, 50. Whoops, I'm getting off a little bit. Okay, so this is 20. And then this would be 31. This would be 43. This would be 50. Once again, I'm just adding. So the next one, 50 plus 5, 55. 55 plus 8, 63. 63. 63 plus 6 is 69. Okay, so that's all we have to do for cumulative frequency. Now part B says represent the data on a cumulative frequency graph. So we gotta plot this. So I'm gonna zoom out, put that right there. Okay, so if we're just looking at minutes, we don't have anything until 1:46, so it doesn't make sense to do anything before that. And so we're going to say right here 1:46, right here 1:50, right here 1:54, 1:58, 1:62, 166, 170, and then 174. Okay. Then over here we can just say 10, 20, 30, 40, 50, 60, 70. Okay. Now, what we're gonna do is at like in between these times, so we're gonna plot this like it's a 1:47 essentially. 1:47 or 1:48. We know that there's 8 people that have finished the race, and then about 1:50 or so we have 11 people who have finished the race. And then in between this time interval there's about 20. So we'll do that. Then there's 31 when we get to this one. And then there's 43 when we get to this one. So maybe right there. And then there's 50 when we get to this one. And then there's 55. And then there's, when we get to, let's see. And when we get to all the way over here, we get to 63. And then almost off the graph, we get to 69. Okay, so if we were to plot that, in 1:46 would be 0. If we connect the dots, we make a graph that looks kind of like that. Once again, look in your book if you want to see a better drawing of that, but that's kind of the process. Basically, we're just using this as an x value and this as a y value.